viewers, welcome to my YouTube channel. So in today's class, we're going to discuss fundamental and derived quantities. Fundamental and derived quantities. This topic is specially designed for early year 10 students to help them with the knowledge of physics. So at the end of today's class, you'll be able to distinguish between fundamental and derived quantity. You'll be able to determine the dimensions of physical quantity. You'll be able to identify the basic units and quantities. So measurement is very important in the field of science, especially in physics. So before any fact or law is accepted in physics, such facts must have been accurately measured and quantified. So every measurement requires two things. These are quantity, or we call it number, then we have units. So every measurement must have quantities and units. Quantities and units. That's why unit is very important when you're solving question physics. So what are physical quantities? Physical quantities are quantities that have measurable physical properties. Examples include temperature, mass, time, speed, power, area, acceleration, velocity, etc. And these quantities can be classified into two categories. The first one is fundamental quantities, and the second one is derived quantities. So let's discuss what fundamental quantities are. So fundamental quantities are the basic quantities that are independent of other quantities, upon which other quantities are derived from. Now, let's discuss these fundamental quantities one after the other. The first one we're going to talk about is length. Length simply tells us how long or short an object or distance is. Length is also regarded as the distance between 2 points A and B. It is denoted by letter L, measured in meter, centimeter, kilometer, as the case may be. We have several instruments used in measuring length. We have the ruler, tape, vernier caliper, micro screw guide, yardstick, and measuring wheel. So length is regarded as a scalar quantity because it has only magnitude, no direction. It has magnitude, no direction. The next one we're going to discuss is mass. So what is mass? Mass is the quantity of matter present in a body. Mass also tells us how heavy or light an object is. Mass can be denoted with letter M, measured in gram, kilogram, centigram, as the case may be. We have several instruments used in measuring mass. We have the lever balance, beam balance, the chemical balance, and other instruments that can be used to measure mass, such as digital scale, which is mostly used in the laboratory. And mass is also a scalar quantity because it has only magnitude but no direction. You cannot tell the direction of mass, but you can measure or tell the amount of mass. Now, the next one we're going to discuss now is electric current. So electric current is the rate of flow of electric charges. Electric current is the rate of flow of electric charges through a conductor. And electric current is denoted with I, measured in ampere, and the instrument used in measuring electric current is called ammeter. Electric current is also regarded as a scalar quantity, though in the definition it shows that it flows through a metallic conductor, but it is a scalar quantity, not a vector quantity. Now let's discuss the next one, which is time. What is time? Time is the duration of an event. It is denoted with letter T, measured in seconds, minutes, hour, etc. We have several instruments used in measuring time as well. We have the stopwatch, we have the wall clock, we have the pendulum clock, etc., digital clock, and many more. So time is also regarded as a scalar quantity because it only have magnitude but no direction. Let's discuss about the amount of substance. Amount of substance. So the amount of substance tells how many particles, such as atom, molecule, or ion, are present in a sample of matter. So amount of substance is denoted with letter N, mostly in chemistry, and it is measured in mole. Amount of substance is also a scalar quantity, not a vector quantity. Now let's discuss about temperature. What is temperature? In common definition, temperature is the degree of hotness and coldness of body. But in physics, temperature is a physical quantity that determines the direction or flow of heat when two bodies are placed in contact with one another. Temperature is measured in Celsius, Kelvin, Fahrenheit, Rankine. It is denoted by a sign called theta. We call it theta. It is denoted by temperature is denoted by a symbol called theta. Temperature is measured with an instrument called thermometer. Temperature is also a scalar quantity because it has only magnitude but no direction. Now, the next one we're going to discuss is luminous intensity. So, luminous intensity tells us the brightness of light from a source. It also tells us how much light energy a particular source gives out per seconds in a given direction. So, it is denoted by capital letter I and small letter v. It is measured with an instrument called photometer. It is measured with an instrument called photometer. And the unit of luminous intensity is called candela. It is called candela. That's the unit of luminous intensity. So in summary, fundamental units are the basic units from which other units can be obtained. And the common symbol we're going to be using in our dimensional analysis include capital letter M, capital letter L, capital letter T, capital letter I, IV, and theta. We also have mole. We're going to be using in case we have any quantities in chemistry that require dimensional analysis. So let's proceed to derived quantities. What are derived quantities? So derived quantities are quantities that are obtained by a combination of two or more fundamental quantities. Derived quantities are quantities obtained by the combination of two or more fundamental quantities. So the first example of derived quantity we're going to discuss is velocity. So what is velocity? Velocity is the rate of change of displacement with time. It is also the speed of an object in a specific direction. Velocity is denoted by letter V, measured in meter per second. Mathematically, velocity is equal to displacement over time taken. Now, displacement also represents the gap between 2 points in a specific direction. That's why we have the unit to be in meter, and the unit of time is in seconds. So the unit of velocity is going to be meter per seconds. So velocity is regarded as a derived quantity, and it is a vector quantity because it has both magnitude and direction. Now the next one we're going to discuss is volume. Volume of cube. Volume of cube tells us the amount of space occupied by substance or object. The amount of space occupied by an object or substance. Volume is denoted by letter V, measured in meter cube. Mathematically, volume of a cube equals to length times breadth times height. And length is measured in meter, breadth is measured in meter, height is measured in meter. So when we multiply these together, it's going to be having what? M raised to the power of 3, which is what? M cube. So volume is regarded as what? As a derived quantity because it consists of three fundamental quantities, which include the length, breadth, and height. So volume is a scalar quantity. It has magnitude but no specific direction. So let's discuss density. Density is the mass of an object per unit volume. It is denoted by rho, measured in kilogram per meter cube. It is denoted by rho, measured in kilogram per meter cube. It is a derived quantity. Density is a scalar quantity because it has only magnitude but no specific direction. So other derived quantity include the area, which is length and breadth. The unit of area is what? Meter square. It consists of what? The length and the breadth. It consists of the fundamental quantities, length and breadth. So the next one we're going to discuss is acceleration. What is acceleration? Acceleration is the rate of change of velocity with time. It is denoted by small letter a, measured in meter per second square. Measured in meter per second square. It is a vector quantity because it has both magnitude and direction. Mathematically, acceleration is equal to change in velocity over time taken. And you can express this as A equals to V minus U over T. Let's discuss about force. What is force? Force is a push or pull, and it is also regarded as an agent that tends to change the position of an object either on a straight or circular path. So force is denoted by letter F, measured in Newton, or you can say kilogram meter per second square. But generally, we use Newton as the unit of force. Now, force is a vector quantity because it has both magnitude and direction. Now, let's discuss about work. What is work? Work is the product of force and distance moved in a specific direction. It is the product of force and distance moved in what? Specific direction as a result of applied force. So, work is denoted by letter W, measured in joule. Work is measured in joule. Mathematically, work is equals to force times distance. Work is equals to what? Force times distance. And work is also regarded as a scalar quantity because it has only magnitude but no specific direction. Now let's discuss about power. What is power? Power is the rate at which work is done or the rate at which energy is expanded. It is denoted by small letter p, measured in watts. Mathematically, power equals to work done over time taken. Power is a scalar quantity because it has only magnitude but no specific direction. The next one we're going to discuss is pressure. What is pressure? Pressure is the force acting perpendicular to the surface area of an object in contact. Pressure is the force acting perpendicular to the surface area of the object in contact. Pressure is denoted by letter P as well. So pressure is measured in Pascal or Newton per meter square. It is either measured in Pascal or Newton per meter square. Pressure is a vector quantity because it has both magnitude and specific direction. So other derived quantity we are still going to discuss as we proceed in our dimensional analysis include speed, moment, momentum, weight, impulse, etc. So if you have not subscribed to my YouTube channel, kindly subscribe to my YouTube channel and press the notification button so as to receive every new video I'm going to be dropping on this channel. So in the next class, we're going to start with what? Dimensional analysis. So stay tuned.